Hello everyone, I hope all of you are doing well. So today we'll discuss one problem from Leetcode, that is generate parenthesis, and the problem number is 22. So the problem statement is saying given n pairs of parentheses, write a function to generate all combination of well formed parentheses. Means you will be provided with one number, say n equal to 3. That means you will get 3 open bracket and 3 close bracket, and combining all of them you have to form well formed parenthesis. That means whatever will open first, then it will be close. And if you see, all are correct equations, right? So if you take these examples, these are not well formed parentheses because it opened, sorry, closed first, then it is opening. So this kind of combinations are not allowed. All combinations should be a well formed parenthesis. So here if you take n equal to 1, then only one possibility is there. So it will open first, then close. So the problem statement is we have to will be given with number from 1 to 8, and we have to form all the well formed parentheses which are possible. So now let's see how we can solve this kind of problem. So suppose n equal to 3 means we will get 3 open bracket and 3 close bracket. Now, one thing is confirmed that the output string will be of length n into 2, right? So in this case, it will be 3 into 2, 6. And we will get all the output combinations which are valid. And if you check, all of them has length as 6. Now, how to solve this kind of problem? One thing is clear that we have to first start with one open bracket, because initially we can't start with a close bracket, then that will be a wrong answer, right? So initially we have to start with a open bracket. Then we have choice, like we can add one open bracket with it or a close bracket with it. So either we can go for a open bracket, we can add one more open bracket with it, or we can add a close bracket with it. Then from here also we have same choice, either a open bracket or one close bracket we can add here, and all of these are valid. So here also we have two choice, one like open bracket you can add or one close bracket you can add. But here if you check, this is not a valid string, because here the number of close bracket is more and open bracket is less. So further on we can't move with this, so we have to cross it, or we don't have to take it into the consideration. All these are valid till now, whatever we did. Now from here also we have choice, like we can add one close bracket in this case. Why? Because open bracket is finished, because open bracket only we can use 3. So 3 is over. Now only we can use is close bracket. So that's why there is no open bracket we have added. Now from here if we add one open bracket, that is valid. If we add a close bracket, that is also valid. Now here if we add one open bracket, that is valid. Then if we add one close bracket, that is also valid. Here if we add one more close bracket, that is valid. Here if we add one close bracket, that is valid, because here also we can't use another open bracket because we already have 3 open bracket. Now here what we can do is we can use another open bracket. Okay, from here. Here also what we can do is we can create one close bracket, because already open brackets are finished. So now here also we can use one open bracket only. Okay, and one close bracket also we can put, but this is not a valid scenario. Okay, because here the number of close bracket is more, so we can't proceed with this one. Now next time what we can do is we can uh, put one close bracket here, and this is one result, because this already reached the length of 6, so this we can collect as a result, and this one it is. Then here also we can put one close bracket and finish, because we can't add an open bracket, and we got our second result. Then we got our third result by including one close bracket. Here also we got our result by including one close bracket. Here also by including one close bracket we got our result, and that's it. Now if you check here what kind of traversal we did here. So if you check, first we start with this one, then we added one left side and right side. Then in this level we went for left and right, then left and right. Then each and every level we are going left and right checking. So this is one BFS kind of traversal we are doing to generate the result, right? And obviously to do a BFS traversal we need a queue. So I will just show you few steps how you can use Q to get the result. So first you have to insert this one. Then what you can do is you just pop this element and add a open bracket and a close bracket and check if it is valid, then you put it back into Q. So if you add one open bracket with it, that is a valid result and you can keep it in the queue. And if you add a close bracket, then also it is valid and you can keep on the queue. So all three are done. Then you have to pop the first element. Then again same thing you have to do. You have to add one more open bracket and you can add one close bracket. Okay. And every time when you are putting back into the queue, you can check that is valid or not. If it is not valid, then no need to put it in the queue. And at the end, whenever you will pop, that time if you check the length is 6, just collect it in a result set. Okay, then you will get the answer. So this is the way, if you use the BFS technique, then you will get the result. And for validity purpose, whenever I am checking that the string which is going to form is valid or not, for that purpose you can create a function where you can keep the count of open and close and the character which you will just insert. Suppose max mean 3 here. Okay, so if open is already 3, then if you want to add another open, that time it will be false, right? That is not a valid condition. If your close is already reached the maximum, means 3, and if you are try to add another close bracket, then that is also not valid, so you have to return false. If open and close both are same, that time you can't add a close one, because always open should be greater than close, but not less than. It can be equal, but not should be less than close, right? So that case also it will be return false. Any other case it will return true. So every type you have to check that if it is valid, then only you have to proceed. Now I'll show the program for it. The problem is simple here. I have defined one class generate parenthesis 2 because I will show you another method or another approach. That's why I named it as a 2. Okay. So we have to take one list of string result, which will be our end result. Then I have created one variable called max, which is actually n equal to 3. Okay. Then I have created one class here, that is bracket, which will have the number of open, close, and the value of the string. Okay. Now from the main method I am calling this one. Okay, so this will be our starting method. So where I am taking the input as n and I am assigning this to max. Okay, then I am doing a BFS and at the end I am sending the result back. So in the BFS what I am doing, I am defining one queue of type bracket, which is the our class. Okay, so in the bracket class, first we are adding one open bracket, and that time open bracket count is 1 and close bracket count is 0. Next, all of the operations we will do until the queue is empty. So first I am polling something or dequeuing an element, and then I am checking if the element length is max into 2, means 6 or not. If it is 6, that means we got one result, so we will add it in the result, the value part. Or else what we will do is we will check if it is valid or not, means I want to put one open bracket and this is my current open and close bracket number. Okay, so it will go through this method. If this method will say yeah, you can go ahead, no problem, then we will add that element into the queue. And that time if I am putting one open bracket, then that time I will increase the number of open bracket to 1 and close will be same, and value will be value, whatever value already there. With that I will add one open bracket. If the other part is valid, means close part is valid, means open and close, if I want to add one close bracket, so that time I'll do a close plus 1, and in the string also I will do a plus close bracket. If that is valid, then both of them we will put. So it can be possible that open is we are allowing but close is not allowed, right? So if both are valid, then both we will add using one like open, one by closing. And when the queue will become empty, that time we have collected all the values in the result. So here if we check, the input is 3, right? Okay, so if we run this program, so we got the output, all the combinations it is printing. So another approach I will show you using DFS backtracking, and this is actually faster than the BFS one. So here the thing is almost same. So what we can do is first we will open one bracket, then one of the path will complete and then come back. So then we'll jump into this, then we'll create this, then we'll create, then we can again come back here by deleting one and then adding again, and after that we can complete like this and we'll get all the result. Okay, so if I show you the program, you will get to know this. So this is the program where DFS backtracking is used, means recursion is used. So it is also similar actually. So here I have created all the possible characters, means one left bracket open and one close bracket. I have kept it in an array. And then this is the final result array list. And I am using one string builder because you know, right, in Java actually if you muted the string, then it will again create a new string, right? So you can use a string builder in this case. And this is the max variable. So this is the main method from where I am calling it generate parenthesis. So I am assigning the n to max, and then I am starting a backtracking with 0 and 0. Here 0 and 0 means initially open bracket is 0 and close bracket is also 0 as count. When I am entering into the backtracking method, the first thing I am checking is if the string is already formed or not. How to check that thing? If the length of the builder string is max into 2, that means 3 into 2, 6, that means it is already completed. So I can collect it as an answer. So if it is that the case, then result.add builder.toString and we will return true. If it is not the case, then we will return false. Now we have two choices. Either we can add the open bracket or the close bracket. So if we iterate over the characters array here, so once we will add the open bracket, one we will add the close bracket. So suppose first we have to start with the open bracket, right? So when we will do a open bracket, that time we are checking it's valid or not. The valid function is same, whatever I have shown you earlier for BFS. So I will just check that this is my current open bracket and close bracket number, and I am going to add this particular character. So will it be valid or not? If this method is saying yes, it is valid, then we can proceed, and in the builder, like string builder, we can append the character C. And then again we will call this backtracking method, and that time if we are appending on open bracket, that time we will do open plus 1. And if we are appending one close bracket, that time we will do a close plus 1 because open and close count will increase according to that. And then again we will enter into this method. But for backtracking or DFS, you know, right, from a node, when I am going to a depth of something, we have to return back, and from that node we have to take another path also, right? So whenever we are appending, while returning we have to delete also in same fashion, right? Because from one node, suppose I am taking one path like this, then from that node, while coming back we have to take another route also, right? So that time we have to form the original string. So that's why it's a builder.delete caret in the builder.length minus 1, right? So as it is calling recursively, we have to come back also. So now if you run this one with input 3, we will get all the strings. So now for better understanding purpose, like how this recursion call is happening and how the strings are forming, so what I did is I put one private in step variable, and I am printing few variables here. One is step, then the string actually, and open and close. So if we run now, the complete trail we can see. So see here, in step 0, open and close both were 0. Then in step 1, just one open bracket is there. Then in step 2, two open bracket, then 3. Then when the 3, well, like all the open bracket is finished, then we start with the close one. Then again we added the close one, and here I am getting the result because here open and close both are same, right? Means we are collecting that one. So first result we got. Then what we are doing is we are again adding one open bracket from step 2, if you notice here. So that's why this delete method is used, because I came till this way, then we are going back again. Okay, from here we are again starting one DFS call. Okay, so and at the end we are getting all the result. So if you notice here, wherever open and close is same, like 3 and 3, there only we are getting the result. So here one result we got, then here one result we got, here one result, here. Okay, so that's it about all the uh, parenthesis 1 and 2, both the solutions. You can submit all this in Leetcode, both will run properly. Okay, the DFS one will take one less time. Thanks for watching.